Okay, so a molecule is more than one atom stuck together, but not any type of atom, more than one non-metal atom stuck together. Where do we find the non-metals on the periodic table? Tell your partner, where are the non-metals on the periodic table?
What happened? Okay.
So if you recall, you would draw your staircase on the periodic table starting at boron, and you go down, and then you go across, and then you go down, and then you go across, and down, and across, and down, and across, and down, and across, and down, and across. Everything to the right of that is your nonmetals, and everything to the left of that is your metals. Now, we also have, what do we call the ones that I've highlighted in blue? Metalloids. Yes, very good. What do we call groups 1 and 2 and groups 13 through 18? Those are your main group elements. Good. And what do we call the ones in between? Transition metals. And what do we call these guys here? Lanthanides, and these guys here are called the actinides. All right, and what do we call group 1? Alkaline metals. What do you call group 2? Alkaline earth metals. What are the charge of ions formed by group 15 elements? What charge ions do those form? That's trickier. Well, it's one of those two. I got people saying 3 negative and people saying 3 positive. If we're in group 15, how many valence electrons? 5, because if you're in group 16, it is 6 valence electrons. In group 17, you have 7 valence electrons. If you have 5 valence electrons, are you closer to full or closer to empty? You're closer to full. So what are you going to do? Gain or lose electrons? Gain. How many? 3. What charge are electrons? So it's going to be 3 negative. Okay? All right. You guys sound like you're ready for tomorrow's test. Okay? We'll have a little bit of a review at the end. Don't worry if you're missing all of this stuff. It's totally fine. Okay? No worries. All right. So where were we at? We were here. Bonding. There we go. Oh, no, not that one. There we are. Okay. So we had more than one non-metal atom stuck together, and these are molecules of elements. What does it mean if I have an element? Only one type of atom. So if you have 2 atoms stuck together and they are the same, you have a molecule, and it's a molecule of an element. And our example of that was hydrogen, 2 hydrogen atoms. And remember, hydrogen is a nonmetal. And so we have a nonmetal plus a nonmetal. And when we have a nonmetal and a nonmetal together, we get a molecule. So there's our hydrogen molecule. And we are going to write the symbol. Whoops, symbol has an M in it, which I totally forgot. Symbol for a hydrogen molecule is H, but we have to do something else with it. We're going to put a 2. Now, I got some questions for you. Is it going to look like this? Or is it going to look like this? Or is it going to look like this? Which one do you think? Is it the first one, the second one, or the third one? It's the second one, yeah. So the 2 is going to go down at the bottom. That's because something else, if we have one, goes at the top right. What goes at the top right of a symbol? The charge. So if you have a charge, we need to leave that gap open for a charge. Oh, and if we were doing just plain old hydrogen, this is again for your test tomorrow. Let's say we had the number 3 up here and the number 1 down here. Tell your partner, what does that number 1 tell you? That number 1 is, what do we call that number? That is the atomic number. What does it tell us? Tells us the number of protons. What is that number up top? That's the mass number. And what does that number tell us? That is the protons and the neutrons added together. Okay? Excellent. All right. So this hydrogen molecule, and if you recall from last day, each hydrogen had 1 electron in its outer shell. Is that stable or unstable? Unstable. Is that high potential energy or low potential energy? High potential energy. Does nature like to be at high potential energy or low potential energy? Likes to be at low potential energy. What would make that hydrogen more stable? Another electron. And so what they do then is they share electrons, and they each end up having 2, which has filled up the first shell. So first shell is filled with 2. How many fill the second shell? 8. And the third shell? 8. Okay, great. All right. Now, this particular hydrogen molecule, this molecule is always going to contain 2 atoms. So it's made of 2 atoms. And because it has 2 atoms, we call it a diatomic molecule. Because di means 2. So if you say diatomic, that means literally 2 atoms. If you had a 3-atom molecule, what do you think you would call it? Triatomic, okay? However, it turns out that being diatomic is fairly common in the element world. So for example, nitrogen and oxygen and chlorine also exist as diatomic molecules. So do bromine and iodine, and I think there's another one, fluorine. But a diatomic molecule contains 2 atoms. Let's write the formulas for nitrogen and oxygen and chlorine. What's the formula for nitrogen? What's the symbol for nitrogen? N. And because it is diatomic, what would we have to put? We'd put a little 2, because what you really have is you have a little N, and it is stuck to another N. What do we call that, like stickiness? That's called a chemical bond, okay? So that's our N2. When we have oxygen, what would the symbol for oxygen be? We're going to call that O. And because it is diatomic, it would be O, little 2 down at the bottom. And finally, chlorine. Cl. And we have our little 2 down at the bottom. Okay? So a molecule, and here is a new word. A molecule is a group of atoms, but not just any atoms. What type of atoms? Non-metal atoms. Non-metal atoms. And we say that they are bonded together covalently. And when they bond covalently, that means they share electrons. We'll get way more into different types of bonding later. So don't worry too much about that word at this point. Just realize it is a word and we will see it again later. Okay? Now, atoms can join together to make compounds. How do we know that we have a compound? Tell your partner, how do we know that we have a compound? Yes, I am. Yeah, thank you. Thank you for checking though. Oh, yeah. Okay, and we are on. So atoms can join together to make compounds. What does it mean to be a compound? More than one type of element. So you have two or more different elements. Okay, and they mix together in a chemical reaction and they become joined or bonded to one another. That makes a compound. So this little beast right here, this H bonded to an H, is that a molecule? This little one right here, is that yellow one a molecule? Yes. Yes. So we can say molecule. Is it a compound? Okay, so that's a molecule, but not a compound. How about oxygen? Is that a molecule? Yes. Is it a compound? No. So it is a molecule, but not a compound. Oh, we actually got some air. Now, when these two guys get together, hydrogen and oxygen, and when we put a little flame next to those two, it actually makes a nice, great big bang, okay? And you end up with water, okay? Is this a chemical change or a physical change? Tell your partner, is this, when we go from hydrogen plus oxygen and we get water, is that a chemical change or a physical change? That is a chemical change. How do we know that it is a chemical change? Because we got a new substance. The atoms got rearranged into new particles. Okay? So, H2O, is that a molecule? Is it made of non-metal atoms stuck together? Yes. So it is a molecule. Is it a compound?
Oh, sorry. Yes.
Yes, because we have different atoms. So this one is a molecule and a compound. So you can have molecules that are elements, you can have molecules that are compounds. Okay? Molecule just means you've got non-metal atoms stuck together. Element means the atoms are all the same. Compound means you've got different atoms. In a chemical reaction, the atoms become joined in different ways. And this just reiterates, a compound is when you have two or more different elements that are bonded together. Okay? Right. Covalent compounds. Do you guys remember what that word covalent meant? Sorry? Yeah. Covalent compounds have covalent bonds. And if they have covalent bonds, that means they do what with their electrons? They share their electrons. What types of elements do that? Non-metals, okay? So covalent compounds are always made of non-metals. So covalent compounds have covalent bonds. They're made of non-metals. And how do they hang out in the world? They hang out as molecules. So if we were to look at a glass of water up super, super close, we zoom in super, super close, and we're like, oh my gosh, let's look at all of those little water molecules. You'd say, aha, I have a molecule, which is a compound. And I'm going to introduce another new term. Are there any particles in here that are different from one another, or are all the particles the same? Here's a particle. Here's another particle. Here's another particle. Particle, particle, particle. Are they the same or are they different? They're all the same. All the particles are the same. They all look like Mickey Mouse. What would we have done without Disney to tell us what a water molecule looked like? I don't know. And if they are all the same, is that going to be a pure substance or a mixture? That is a pure substance. Since they're all the same, that means we have a pure substance. What is wrong with this pen? It keeps erasing itself. Is this a compound or an element? Water. Water is a compound. Are compounds pure substances? Yes. Okay, this is a pure substance. It is a compound. And from the fact that it is both a compound and a pure substance, we can infer that compounds are pure substances, unless we go mixing one compound with a different compound. But any single compound is a pure substance, okay? So this unit has a lot of vocabulary, okay? We got atoms and we got molecules, both of which are particles, yeah? And we've got covalent bonds and we got pure substances. Now, how about in our, what do we call these things? Fire extinguishers. This is our fire extinguisher here. What substance is in that fire extinguisher? We have C and two O's. Can you guess what the name of that is? It is CO2, okay, because we have C and we have two O's. Does anyone know the name of CO2? Oh, it's right there. Yeah, I know. It is carbon dioxide. Why do we have that little di there? Because there are two oxygens. So this substance here, are those molecules? Are those molecules? Yes, they are molecules. Are they compounds? Yes. So this is a compound. Is it a pure substance? Yes, because all the particles are the same. Ooh, I ran out of room. Uh-oh. All particles are the same. I read like a little meme the other day. Wouldn't it be fun if we started pronouncing anything that ended in CLES as cles, like Heracles, like there's the in Greek. So these would be particles. And Isocles, yeah. I don't know. 6, 7. Have I saved myself? No. Okay. Never mind. All righty. Oh, while we're here, what is the formula for water? H2O. Hopefully we all knew that one. Is it H2O or is it H2O?
H2O.
It's H2O, not that one. Okay? The little 2 has to go down at the bottom. Okay? We're going to just start on this and then I'm going to give you time to work on your reviews. Okay? Crystal lattices. Up till this point, what types of elements have we been bonding together? What types of elements have we been bonding? Non-metal and non-metal. Now we're going to bond metal plus non-metal. Okay? This is not a molecule. Okay, this thing here, not a molecule. The reason it's not a molecule is, can you see how it is a repeating pattern? Silver, green, silver, green, silver, green, silver, green. And I could make this cube bigger, and I could make this cube smaller, right? I could make this cube 1 billion ions across and 1 billion ions wide. Or I could make it 30 and 30. Do you know what I mean? Like it can change in size. Can I change the size of water? No, water always has 1 oxygen and 2 hydrogen. How about carbon dioxide? Can I change carbon dioxide size? No, every carbon dioxide molecule has 1 carbon and 2 oxygens. But this is salt. Can I have a big salt crystal? Yeah. Can I have a little salt crystal? Yeah. That's one of the reasons why this is not a molecule. Molecules have a definite size, right? We say a definite composition. What it means is that carbon dioxide never has any more or less than 1 carbon and 2 oxygens. Okay? But in this case, we have an alternating crystal where it goes positive ion and then negative ion. So we alternate positive ion, negative ion, positive ion, negative ion. What type of element makes the positive ions? Metals. So metals are the positive ions and non-metals are the negative ions. How did the metal become positive? This is like for your test tomorrow. It lost electrons. How did the non-metal become negative? It gained electrons. Are these guys sharing their electrons? No, metals are giving, non-metals are taking, not sharing. So is this a covalent bond that's sticking them together? No, because covalent bond is all about sharing electrons. So we need a different name for this kind of bond. So the bond that we have here, this little bond right here, is called it's made of ions. Can you guess what it's called? An ionic bond. And you get an ionic bond when you don't share, when electrons are given and taken, you get a positive ion and a negative ion. Okay, and this 3D crystal is called a crystal lattice. Lattice. Not a crystal lettuce, but a crystal lattice. And it is indeed a three-dimensional structure, but sometimes we will only draw it in 2 dimensions because drawing in 3D is hard. Yes? Like, God help me, I would never be able to draw this thing here. I don't even like to think about it because I'm not good at art. So when we write the symbol for these ionic compounds, we're not going to write, like, let's say I looked at this one. I 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 5, 6. 6 by 6 by 7. What's that? 6 times 6 times 7. 36 times 7 is 36 times 7 is 252 divided by 2 is this particular crystal has 126 sodiums and it has 126 chlorides. Yes? I just did the math on it, okay? Now, if I look at this guy over here, I have 1, 2, 3, 4, 5, 6, 7, 8 of each. I have 8 sodiums and I have 8 chlorides. And if I just go and I grab some salt, do I know how many ions I have? I have no idea. But what I do know is that the ratio is always 1 to 1. Yeah? 1 to 1. So instead of writing the formula with the actual number, which we really can't know anyway, we use the smallest whole number ratio. So for every 1 sodium, there is always 1 chloride. So for every 1 sodium, there is always 1 chloride. And so for the formula, instead of writing Na a billion, Cl a billion, which sounds ridiculous, we can just write it as NaCl. And if there's no little subscripts down at the bottom, if there's no little numbers down at the bottom, that just means that there's 1 each. Yes? And we do that because who knows what the actual numbers are? We really don't know. And we now have hit the bottom of the page, and we have a half an hour left. Would you guys like this time to study for your test? If you did not get the review, I'm gonna come around with
He's really roll.
I gotta get in this. It's not 4 miles. Yeah, already stable. 18 out of so it's really cool. Like we're so used to water. Anytime you look at anything else like freezing point, right? The freezing point of metals is like nuts. So, like, inverse. Anybody else want a next review of atomic experimental models? Hi. It's in here somewhere. Let's find it.